After talking about SR NAND latch and SR NOR latch, now we'll be talking about D-Latch. As you have seen in the previous tutorial that there was a case was not used case. In order to eliminate the not used case, we have come up with a solution named as D-Latch. D specifies data, and as you know, SNR is nothing but set reset latch. So what I have done is in SNR I have for the SNR same version, just only a modification is for SNR. In order to eliminate the case 1 and 0 0, I have used a NOT gate. That means the cases would be when S is 0, R is 1, and when S is 1, R would be equals to 0. So this is the case how we have trying to design. Let us see how the circuit works. So as I am using NAND gate, so if it is 0 0, the truth table for the NAND gate is been shown over here. Now as enable is the switch, if enable equals to 0, if any one of the input is 0, my output is always high, so this will be 1 for the case enable equals to 0. As if one of the input for NAND gate is 1, that means I cannot comment on the output, so it is called as memory. Moving on, the case when enable equals to 1, as you can see, if enable is equals to 1, this will be nothing but D bar and this will be equals to D. So let me take the case when D is 0. So this will be equals to 1 as it is D equals to 0. So 0 and 1. 9 would be 1. And for if this D is 0, this will be 1. For 1 and 1, my NAND would be equals to 0. As you know, if any one of the input is 0, my output will be 1. So this one is sorted over here. So 1 1 1, the output is 0. That means Q of T is 0 and Q of T bar equals to 1. Let us see what happens when D equals to 1. So if D equals to 1, this is 1, this will be equals to 0. If any one of the input is low, output will be equals to high, and for 1 and 1, the output will be equals to low. If any one of the input is low, my output is high, so this one will be sorted over here and my output will be 0, implies Q of T equals to 1. So this is the basic truth table for the D-Latch. So as you can see, if data is set to be 0 and say this is enable we have provided, and if data equals to 0, when enable is high, so if D equals to 0 implies Q of T equals to 0, and if D equals to 1, Q of T equals to 1. That means it is output is basically following whatever the input we are providing. So this is a very useful latch in order to design registers and counters. Hope this is clear to you all. Thank you.